Okay, so we're gonna do the course activity for Unit 4. Angle, angle, side, and side angle criteria. So we're gonna see about it involving similarity. This, so when we talk about this, we're just talking about if you can use a scale factor to make it bigger or smaller. So it's kind of like the activity we did before where we proved that they were congruent, except in this case, when you're dealing with a scale factor, like if this is 2 and this is 4, this could be, I don't know, 3, 6, 4, and 8. There's a scale factor. In this case, the scale factor is 2. And you can always figure that out by doing the new one over the old one. And that works for anything. So you can always do this over this, and you'll see that anything divided that way will end up giving you the same result. So 6 divided by 3 is still 2, 4 divided by 2 is still 2, 8 divided by 4 is still 2. So that's what we're trying to prove with all of these theorems. We're trying to see if it's true, if all of these give us a similar triangle. So that's the goal going into it. So investigate similarity using technology. That just means we're going to use GeoGebra. So we're going to try to prove these theorems, and this is how you get graded. So I'm going to mainly do the activities. I'm not going to like answer the conclusions from it. So all of these angles should be different. They should not be the same as this because you're creating your own triangle. So we're going to open up GeoGebra. And you guys should make a triangle. So you go to polygon, make your triangle. So there's a triangle there. And then what we're going to do here is just record all of the angles inside here. So if I want A, I want to go counterclockwise. So I'll go from B to C. Boop, boop, boop. And then I'm going to go from B. So I want to go counterclockwise, which is the opposite of a clock. So boop, boop, and boop. And then this one, we would go A, C, and then B. And then I would record these. I'm not going to record them right now because, well, I'm not doing the assignment. But all you would do is, if it says angle ABC, obviously you would write angle B in that spot. So it's always the middle angle. If they're asking for ACB, they're asking for angle C. So that's all you're doing for this one. You're just transferring those over. In this one, now we have to do this. Now our goal, it helps knowing what the goal is. What they're gonna try to tell us to do is they're telling us to make another so let's say we have this angle A. Let's say we have this angle ABC here, right? They want us to make another triangle and we're going to see if it's similar. So that's the goal that we're doing here. Oops, this should be E or DEF. Oh, good job, Victor. You don't know your alphabet. So D, E, and F. So we're going to try to make another triangle and then we'll try to figure out if it's similar or not. So that's what we're going to put. This whole question is just that. So we need to follow these directions. So it says make a line DEE any length anywhere on the plane, not on top of ABC. So they just mean don't like cover it up. Don't cover this up. And here's a tip when you guys are doing this for your assignment, make it look somewhat similar to however you did AB. If you can get it parallel, great. If not, try to get it as close to parallel as possible. So we're going to make a line segment and we're going to go from here, and I feel like making mine's bigger. So I'm going to make it bigger than AB. Oops, I did not want to do that. Undo. I hate how you can't. Oh no. There we go. I was going to say, I hate how you can't undo, but it did undo. Okay, so it's not exactly parallel, but close enough. So that's what it meant by draw this anywhere. Now it's like choose one of the angles from point D, an angle same as the one you chose. Draw. So this is just saying that they want you to pick an angle from this triangle, right? Obviously, you don't really have a choice in the matter. It's saying choose it from line D. I mean, you do have a choice, but what I'd recommend is just copy angle D. If you're going to make an angle with A, make it the same angle here. I said those backwards. Use angle D. If you have to make an angle with D, you might as well make it the same as A. So that's what we're going to do. We're going to copy this angle. So I'm going to do, and if you notice here, the angle should go, if you're going from E to D, it should end up going with counterclockwise. So just keep that in mind. Because I want my angle to be this way, it's going to swing from here to wherever this is. So that's counterclockwise. So when I do this, I'm going to do given angle. So I'm going to click E, D, and my given angle should be 103.7. And I want it counterclockwise, which it already is, so that's good. And you'll see that it looks the same. If you did it the wrong way and you're like, oh, that doesn't look like the triangle at all, just redo it and put the other side. So if it wasn't supposed to be clockwise or it wasn't supposed to be counterclockwise, do the other one. So we did that angle. So choose one of the angles, blah, blah, blah. Draw a ray through that angle. You should now have an angle that's congruent. So what we're going to do here is we're going to go back to our lines, but we're going to pick ray, and we want to go from D to E, and it creates this line. So we don't know how much of this ray we're going to use. So that's why they're like, start here and just go on forever, and we'll see how much we use later. So now they're saying create a point anywhere outside the mouth of the opening you created. So outside the mouth, they just mean not in this V. Now, if our goal is to make a triangle, obviously we're not going to want to pick it over here because we want this E to connect to the line. So they want us to be over here. So I'm just going to pick any random point and I'm going to put it, I don't know, like here. Okay, so I made a point outside the mouth. Create a point anywhere outside the mouth or opening of the angle you created. The point will initially be called F, but you should rename it G. I hate that they do that because they don't really tell you how to do it. So the way you rename it, you want to click it, and then you want to go, and then you can right click it. If this doesn't work for you, like if you don't know how to do that, what you can do is just find it here, go to settings, and you can name it right here. And then you just hit enter and you see that it changed the name. So that's two ways of doing it: right clicking it or locating the point that you want here and just going to settings and change the name. Those are two ways to rename it. So now you have your point G. You're going to draw a line from E all the way through G. So that's why I said that you didn't want to have your outside point over here because that wouldn't look like a triangle at all. So we're going to draw a line from here to G, and they want us to, where is it? And if you guys are having trouble catching up, I am going to post this on YouTube later. So you guys don't have to worry. Now we want to find it going through there, your creation, closer to a triangle. So we want to label the point of intersection. Normally what I used to do before was I used to just grab a point, but there's actually a really useful tool that I found called intersection. You literally just click the lines and it'll make the point for you. So there's my point F right there. So this is the triangle that we're claiming is similar to that one. And I can zoom out. We can see already that it's not. So let's kind of take a look. Okay, so we labeled that F. Now click on G and move it by moving it and change that, keeping the angle fixed. G along the line, you can change angle E and angle F. Oh, I see. While keeping that one fixed. So what they're saying here is we can change these two angles literally by just doing this. So let me show you what I mean by that. So angle, I want angle E, so I want to go counterclockwise. So I want to go from F to D. I want to go counterclockwise, so I want to go from D to E. So if I zoom in, you guys can see it a little better. Let me move these out of the way. So by moving this, these two angles change, but this one stays the same. All right, so now what I'm gonna do, let's see, it says take a screenshot. So if you guys don't know how to take a screenshot, all you do is you go to either download as or export image. I like export image because that way you don't have to figure out what type of file you want to save it as. It already saves it as a thing. So you go to download image, save the name. I'm gonna save it in my downloads. I just cleaned up my downloads, so there's nothing in there. It was slowing down my computer, having way too much stuff. I think I deleted like gigs of information. So let me erase all this. So then you want to go to your image. You want to go to your computer, choose a file. I put it in my downloads. I'm going to go to my downloads and upload it. So that's how you do the construction for this. The rest is literally asking questions. So it wants you to make different angles. So it's going to want you to measure angle E, measure angle F, measure angle D. It wants you to measure all the angles basically. So give me a second here. So your angle D should never change. So I can tell you that right off the bat, your angle D is never going to change. So this one should always stay the same no matter what. These will change. So you can see that on their example thing. They're going to change. So just record 8 of them, and you're going to try to essentially try to match. Oh, it actually says record 5. So if you read the directions, you don't have to do all 8. You only have to do 5, at least 5. And I won't grade you down if you do only 5, because if the directions say at least 5, that's all you have to do. Just do 5 of them. And I think you're going to try to match them. And then the rest of them, move it along, see if it's possible to make a similar triangle. So use what you know about similar triangles to try to figure it out. And then it's going to ask you questions like, how many triangles can you make? How many, or decide whether you can make them similar or not. Is it enough to say that they're similar? And by is it enough to say that you have that one was known as side angle? Which one was this one? Actually, it tells you in the top. This is known as angle. So what makes them similar? So just answer those questions. to decide whether the triangles are similar enough to know one pair of angles. So this one's just saying that if only one pair of angles, are they similar? And that's why they're having you measure all the angles. They're like, if they're similar, all of these should always be the same. So that's an indication that it probably is not enough information to say that they're similar. And just use your own words on describing why that is. All right. So for this next one, it starts off the same. We're going to create a triangle. So let me undo all this till I get to it would have been easier for me to just start another triangle. Okay. So here I am, kind of towards the beginning. It wants us to create a triangle, record all of our angles. So we kind of already did that on the last one. Let me close this. I keep going on this and I don't like it. I'll close this too. Close this too. Okay. So there's our triangle. I think it also wants us to create another. Yep. It wanted us to create another DE parallel to the line segment. It doesn't have to be parallel, just as close to parallel as possible. Otherwise, it would take you forever. Now locate, you can draw this at any length, take place, but not on top of D. So again, these two are the same directions. Now it's saying from point E, create an angle that's the same as that. Okay. So again, we already did that from the last one. And then it's like you should have two angles. Okay, so they want you to do two angles now. So we already did one of them. Give me a second. We already did one, so you guys just need to copy that process again. You're going to go, give me a second, angle a given size, here to here, and it saved it from last time. So there's our angle. Make your ray like before. But this time they want you to do another angle here. So obviously you want to use this angle right here, this 38.06. So we're going to create another angle of given size. We're going to go from D to E this time. Oops. Nope. I don't want to make a ray. I want to make an angle. From D to E this time, you're going to copy angle B, which is 38.06. The reason why they don't tell you which angle to do is they kind of want you to pick any angles you want, but this is the easiest way to kind of do it. So if we look here, this is our angle, and if we're going this way, we're actually going clockwise. So make sure that you're putting the correct sign. Again, if it doesn't look like it's connecting correctly, you probably want to fix that. So now we have this D prime here. We're going to make another ray. We're going to do a ray from here to our D prime. And actually looks very, very similar. Like it looks like it's intersecting, but it probably isn't. What I'm going to do is I'm going to hide that D prime because I feel like it's not letting me hide it. Oh well. So now we're going to do a point of intersection between here and here, and that makes this F. Oh, did I make it the exact same size? I didn't mean to make it the same size. Well, we'll see what happens. Okay, so we have that, and now we are going to take a screenshot of it. So by doing the intersection thing, using that little intersection tool right here, that had me do this. So we want to take a screenshot of it. Before I take a screenshot, I'm probably going to want to take that angle. Angle, I want angle E, so I want to go counterclockwise. So I want to go from D to E, because this is counterclockwise. D, E, DF. E. I'm just going to double check to make sure I did click F because this is very fidgety if I don't do it right. Easiest way to check if you did it right, they don't want you to know, but you can check here. So apparently I did not do this right because this, it should be the same as C. So I don't know. It's off by like a little bit. That might just be GeoGebra being GeoGebra. Or, ah, look, I didn't click point E. I clicked, all right, didn't click point F. I clicked E prime. So that means I didn't click the right angle. So I'm going to have to super zoom in to do this, apparently. Hopefully you guys don't have it that close. Make it a lot bigger next time. In fact, let me see if I can do that. If I make this bigger, it also makes the other thing bigger, so that's not going to help. Great. Okay. Well, okay. That sucks. All right, so I'm going to go start measuring this angle. F, want to zoom in to here. Make sure I click F and not E, and I clicked E. Great. I'm still clicking E, and I don't know how to not show it. Okay. Apparently, if you go to Object and you click Don't Show, it won't show it. Obviously. All right, so hopefully that'll help me with this. If not, we're gonna have some trouble here. Okay. So, and that's gonna be helpful in case you have all these other points that you literally only use once and you don't want it to show. You can just click this settings, don't show, show. Okay, so let's try this again. So we're gonna go here, angle, counterclockwise. I did it clockwise. Counterclockwise. Oh, come on. GeoGebra will let me. There we go. All right, now let's see. Yep. So now I did it right. So be careful with those. Make sure you're clicking the right one. Like you saw, it's really easy to click the wrong one. All right, so this should be congruent now. Spoiler alert for the other questions that follow. So again, you want to do it. Theirs looks a lot better than mine because they were like, let's make it a lot bigger so we don't have to worry about this stuff. All right, so you're going to record all of your angles. They should all be the exact same as here if you did it right. Make sure you do it in the right order though, because they might have shuffled it. I haven't really looked at how they organized it. How do the angles compare from the original triangle? So you guys should know that it's the same. With these two angles fixed, what do you notice compared to that? And then they want you to take the corresponding side. So always do it new over old. So what I mean by that is if you're doing DE, that goes on top, and AB would go on the bottom. So when you're recording this, you want to write. I don't know what it is. You guys know how to take the lengths, but I'll show you right here real quick. You want to take the distance of this and the distance of this. If it's not working out, make sure to just click your A and your B. It's going to be the same thing. But you want to do your DE over your AB, which is the same thing as saying 5.66 over 4.43. And that should give you a decimal. I think Edmentum's cool with you leaving it as a fraction. I recommend leaving it as a fraction. So you're going to use your equation editor to type something like that in. And you're going to type in your sides. So use your distance to type in your sides. What do you consider based off of them? So based off of the fact that the angles, oh, shoot. So I forgot, you actually need to make another triangle on this one. I almost missed this instruction. Dilate that. So we're going to dilate this triangle by this scale factor. So whatever this is, we need to dilate it by that scale factor. So you actually need a calculator for this. I almost forgot they make you do this because I was like, it's obviously similar, so we don't have to do anything else. But Mentum wants you to prove that they're similar by doing a scale factor. So I'm going to go about 2 decimal places. So I'm going to go 1.28. So I'm going to say that my scale factor is 1.28. It might be a little off, but going by the nearest hundredth is really detailed. So I don't think we should go any more detailed than that. So what you need to do to dilate, in case you guys forgot, you need to make a point. I always make my point about the origin. It's just easier that way. And you want to go to your transformation tools. You're going to go dilate from a point. We're going to click the whole shape and click this. So the difference between this one and this one, this is a shape. This one I haven't used the polygon feature. So because this is a shape, I can just click the shape. This one I wouldn't be able to click the shape because it's not a shape. It's just stuff put together. All right, and it wants me to do the dilation factor. So that was that new over old that I calculated. All right, so I'm going to do this, pop that up, and you'll see that this triangle almost looks exactly the same as this triangle. The only difference you would have to do is rotate it and move it over. So if you rotated this a little bit and moved it over, they should overlap. So how do they compare after you did that? So you're going to measure all of the sides and all of the angles. I'm not going to do that because you guys should know how to do that by now. Just use your measuring tools for angles and sides. And then you're going to see how they compare. And spoiler alert, they should be congruent. Just write down why they're congruent. So all the corresponding sides are equal, all the corresponding angles are equal. Just make sure you're writing that down in your proof right here for all of the sides being equal. And this is talking about the new triangle you just made, not the made up triangle that you did right here. You're comparing the new triangle you just made with the older triangle. I didn't mean to say that. So you're comparing these sides with this triangle. What can you conclude? You should conclude that they're congruent. Explain why there must be based on angle. Explain why there should be a series of transformations. Find and perform each such sequence. This one, I don't want you guys to do it too much. There must be a series of sequences because they're congruent. If things are congruent, you have to be able to like rotate, translate, all that other stuff onto it. So this one, when it says find and perform them, it's really hard to perform them exactly. So I just want you to describe it. Like for me, what I would say with this one is if you rotate it, and if I'm looking at it, it looks like I need to rotate. So I would say if you rotate, so if you rotate, and you're going to need to use your apostrophes on this. If you rotate A apostrophe B apostrophe C and translate it, it'll match up with this one. It'll match it overlaps, I don't know how to spell, D, E, F. And technically we should be using the triangle symbol, but I'm not going to hold it against you if you don't. D, E, F perfectly. It overlaps it perfectly because they're congruent. Why must this happen? Because they're congruent. Like I don't know what it meant to wants you to do from there. Based on your, can you conclude that the F? So yes, they are. Can you conclude that they're similar? So yes, you can conclude that they're similar because you can conclude that this original ABC and this DE. So pay attention to how they're labeling it. That matters a lot. This ABC is your original triangle. This is the second triangle you made. So are they similar? And you would say yes, because if you can dilate and use rigid transformation, then they must be similar. Decide whether it's enough to say that these two are. So is knowing two angles that are congruent to another two angles on another triangle enough? Well, based on the fact that we just made up a random triangle, yeah, but just make sure you're using your own words. Again, guys, I know I'm going through it really fast, but I will have this recorded for you guys to go over it later. So let me just delete all this. And I don't know why I'm scrolling up. So now I want to do it for side angle side. So I'm going to create another random triangle and I want to record the lengths of two sides and one of the included angles. What it means by included is it means don't do this. I'm going to measure this, I'm going to measure this, and I'm going to take this angle. Obviously, because it says included, you want to get this angle, not this angle or this angle. All right, so I'm going to just rewind what I did here. Also, don't forget to read when you need to copy and paste pictures. I recommend doing it for like every time you have to touch it, just to be safe, and it's better. My thing is, if you do it for every step, and even if you didn't have to, we can always give you partial credit as teachers for demonstrating that you knew what you were doing. All right, so we have this, and it wants us to measure the sides and the included angle. So I'm going to do that by clicking this and this. It was already set to this. I already saw how it was highlighted blue and it was on the distance. That's how come I knew to do that. All right, so now what I'm going to do here is I will copy and paste that. So I would have this, and they just put like a random length here and a random length there. All right, so now I want to draw DE. So again, I'm going to draw another DE. To prevent me from having trouble with that, I'm just going to draw a really long DE. Make sure it's a line segment. Going to try to make it look as parallel as possible to the other one. Doesn't have to be perfect. That might be a little too big because it's going to cross. I'll just move it over. There we go. So I'm just going to move that over and find and record the length of the corresponding angles recorded there. Now multiply the ratio. So this is telling you to do new over old again. So you're going to take the measurement here, go here, and then you're going to go new over old. So you're going to do 6.87 over, if we're doing DE, we're looking at AB over 4.43. I'm going to erase this. And this will give us some kind of number. I want you to go 2 decimal places because GeoGebra goes 2 decimal places. So it should be about the same round off error. If I go 2 decimal places, 1.55. Oh, and that's not too far off because, okay, so that's good. So we're going to get this 1.55. So you're going to make sure you're having this written down on the side. I actually recommend writing it on here if you can. Yeah, just do that just to save yourself the trouble. Here, 6 point, what was it? 6.87 over 6.87 over 4.43. And that's going to equal this 1.55. That way you have proof. Again, showing more work is better than not showing any work. So now what it wants us to do is it wants us to make another side. Well, this whole time we've been doing, let me move this stuff out the way. We've been doing this AC and stuff. So I'm going to do that. I'm going to take this AC and I'm going to multiply it by that. So in case you're wondering where I got those directions, it's now multiply the ratio calculated from there and record the side lengths. So that's how I got this over and under. So this part right here is asking us to calculate it. Now locate the endpoint of a vertice. So again, what I'm going to do, see using the point as the center of a circle. So what I'm going to do here, what this is saying is like, hey, we need to multiply that fraction we got by one of the lengths that we got. And then we're going to have to find the length of a triangle by using a circle and a radius. Okay? Circle and a radius. So if I want to use AC, I'm going to make this DF. I need to make it whatever DF is, it's this multiplied by that. So that's what you do new over old because you're going to use the new side is going to be a result of the fraction times this. If I were to take 4.43 times this, I would get this just because how division works. So if I multiply both sides, blah, blah, blah. So when I do this, I want to do 4.39 times 1.55. I guess it's better for me to do this. So I'm going to grab a calculator. 4.39 times 1.55. To do 2 decimal places is 6.8. So I want to grab a circle. Center. My center has to be E. And then I want to go out. Oops. Center with radius. I'm sorry. Center with radius. I click this as my center. My radius is the number I got here. So 6.80. 6.80. There's my radius. I really hate the triangle I made. I should have made the sides a little different. These are so close inside that's why I've been having so much trouble. All right, so I'm going to have a length somewhere around this circle. I don't know how far yet. I have a feeling Admentum's going to tell me. Or I don't know, where on the circle yet. No idea. But Admentum will tell me. So now it says, mark a point of intersection with the ray and the angle. Oops, I must have skipped a step. Angle F. So did I totally skip a step? Find the ratio of the length. Draw a ray from DE to DF. Angle that's congruent. Okay. So I didn't skip a step. So you had to do the circle. And now in this step, we're going to do a ray. So what we're going to do is we're going to do this same angle the way we did before. We're going to do, where's my tools for angles? Where's my angle tools? There it is. Angle with given sides. We're going to make sure we click E, D, and we want it to be the same as this angle. So 103.47. Because we're going from B to C, this is going to be counterclockwise. So it's already set up that way. And now we're going to draw a ray. So we're going to draw a ray here to there. I don't like having that E there. Hopefully, when you guys make your triangles, make sure that these two are completely different lengths because they're so close together. You can barely see that E is not on the circle. So it looks like it's already a point of intersection, but it isn't. And that's one of the reasons why I like the new intersection tool. So I'm going to hide my E prime. So I'm going to do that by right clicking, and I'm going to not show the object. There we go. And what I want to do here is go to my point intersection here and here. Now I have a new point F. So I'm just going to draw a line segment from E to F. And this should be a similar triangle. Well, we'll find out if it's similar. Spoiler alert, it's similar. So let's get the measurement here. Where's the measurement? Where's the measuring tool? There it is. From A to F and here to here. We knew this was coming because we made the radius, so obviously it should be the same. If it's not, that means you probably picked the wrong point when you were doing this. And we're going to compare them to this. So that should prove that they're similar. Just make sure you're answering the questions correctly, measuring your angles correctly. Does a relationship between that happen? Yes, they're similar because all the angles are the same. Your constructions are unique based off the nature of this. So by having side, angle, side, since this is a very unique situation, is that enough? It's like, well, yeah, because it's kind of random that we would randomly make a congruent triangle or similar triangle. We're not doing congruency anymore. All right, let me see if I can knock out the last one with the amount of time we have left. I'm hoping we can. I know I'm not going over all of them, and I apologize for that. So, this one's actually, I kind of like this one a little bit. I'm going to create a brand new triangle, guys, because I really don't like how similar those are, and this is going to have a lot of circles. So, I'm going to create a brand new one. I'm going to make sure they all have completely different lengths. So when you make your triangle, make sure they're not that similar in lengths. That should be good. Okay, that should hopefully help this out. All right, so when we're doing this, first notice that my A's here now. So I kind of messed it up a little bit, but it's just going to be a little different. So all my alarms are going off to go to the next class in a bit. So when we're doing this, we want to grab all the lengths. So use our measuring tool, length, click all the lengths. And now what they want us to do is record all of them. So you guys know how to do that. Then it wants you to create another length DE in a different spot. So I'm going to make this one smaller just because I've been doing all of these bigger ones. Let's make a smaller triangle because why not? Oh, I just realized I have to do this to make it. I'll do it right underneath just to make it a little interesting. That way we can still see this one. So I'm going to make a line segment, and this one I'm going to make smaller than AB. And I'm going to need to record it, so I might as well take the measurement now. So there's my measurement. And, oops, That's for the other class. And I want to find the ratio. So I want to do new over old again. So I want to do 5.023 over 3.863. So I'm going to grab my calculator for that. 5.023 divided by 3.863. I don't know why, but this time they're doing 3 decimal places. So I'm going to, doing 3 decimal places isn't that hard for this one. So our ratio is 1.3. That's good. I like that it's not that hard to do. And now what it wants us to do is like, hey, multiply all of your sides by that. So obviously, we don't have to multiply this side because we already did it. We do need to multiply this side. So this is our side AC. So we're going to do 6.745 times 1.3. So I'm going to grab the calculator for that one. 6.745 times 1.3. And I end up getting this 8.7769. I'm going to round. So 6.9. All right. And then I'm going to do the other lengths. I'll do that in red so we can keep track. I'm going to do this length, this BC. So I'm going to do 3.642 times 1.3. Grab my calculator. 6.642 times 1.3. And I get this was 4.7. I don't know why I was saying 1. 4.735. So I have these two sides now. So it's important to keep track of which one's which. So this one is this side right here, this AC. So I want to start it from point D so I can create my point F here. So I'm going to, it tells you in the thing, I've just done this so many times, I like, no. We're going to create 2 circles, one from point D to represent this AC, and the other one from point B to represent the BC. So what we're going to do here is we're going to do a circle with given radius. So the blue one is the one from point B, and I want it to be 8.769. I'm going to hit enter. So we get that. Now I want to do another circle, but this one's from point B. So did I put that one in right? Oh, it's supposed to be dividing. It's a smaller circle. I'm so sorry, guys. I'm supposed to be dividing. I was like, this circle's too big. Because I was supposed to do new over old. So it's not 1.3. It's always new over old. Always new over old. New over old. I forgot my own rule. New over old. The new one is 3.863. So unfortunately, it's not going to be as nice as I thought it was. 5.023. If we do that, we're going to get a fraction, unfortunately. So I did the mistake most people do with this. They assume that the big number goes on top. Not true. So this is going to be 0.769. 0.769 is our ratio. Let me see if I can fix this real quick. I want to delete this circle. So I'm going to go center and given radius. I'm sorry, guys. I'm going to multiply this side by that. So I should be getting smaller sides for this. So 6.745. I think I was such in a rush I didn't get it right. So this is 5.187. 5.187. So we're going to do a circle from here, and it's 5.187. 5.187. 187. Gonna enter that. There's our circle. This makes a little more sense now. Because I was like, how is this line ever going to touch that bigger circle? It wouldn't have. And now we're going to do this side, this 3.04. So we're going to do 3.042 times our common ratio. So we're going to do times 0.769, and we get 2.339. So 2.339. So I'm going to make another circle from E, because we're doing the BC. So I'm going to do from E, and it was 2.339. 2.339. So now we have 2 points of intersection. I'm going to make it do this one. So you want to go to your point of intersection, click both of the circles. It marks a point for you, your point F. Now all you have to do is connect the dots, E to F, F to E. You have this circle now. So in order for me to kind of not have to worry about these circles, what I'm going to do is I'm going to use the algebra tool. This lets me see all these. I want to get rid of the circles, so I'm going to go down to, or I guess up to conics, and I don't want to see these. Or actually, I can just right click them. I don't want to see the circles, so I'm not going to see the circles. This just makes it easier to prove your point. And now what you should have is these two should be similar. So all of these, because you're doing the idea of proportions, let me erase everything. Because you're doing the idea of proportions, oh my gosh. Why is this, why do you make this difficult on me? I'm going to close this. Okay. Because you're doing the idea of proportions, these should all have the exact same angles. It's the same shape. You can see that the shape looks exactly the same. So if you measure the angles, all the angles should be the same. And luckily that was enough time to kind of show you. You can see how they did it. Theirs is a little weird in my opinion. Measure all your angles. Again, if it's angle B, it should be matching up with angle E. So be careful with these because they labeled them wrong. It should be DEF. So, and they labeled it FED. So they're tricking you a little bit here. But, oh, this is bad. They don't copy their sample answer because it's wrong. Because this angle should match up with this one. They have it out of order. It's very weird how they did it. Does there a relationship? So because all the angles are congruent and the sides are proportional, yeah, they're similar. Does side ratio work for all of them? Well, yeah, because we created a random triangle and it worked. So I'll put this video up. I'll add it to the task where I told you guys to do the course activity. So this video will be linked to the course activity on the Google Classroom, and I'll put it up on YouTube, on the YouTube playlist as well.